meters per second. The wavelength is 5.85 times 10 to the negative seventh and times frequency. So to find frequency, we're going to divide here by 5.85 times 10 to the negative seventh. 5.85 times 10 to the negative seventh. And then we're going to divide and get V equals, divide those, 5.1, I forget what the other number was, 2 times 10 to the 14th, and then a frequency is hertz.
Why did they put 3.00? What can you just have 3?
You can if you want to just write 3, but for significant digit purposes, it probably even goes beyond that. They measure out 3.00. Yes. I did not see a hand over here. I'm just losing my mind. You were stretched. Okay. Anybody else have a question on that? All right. So the last question that we had was, what happens when an electron returns to the ground state?
It releases visible light.
It releases visible light. It will go back up, but it releases. You can say visible light, but does it always have to be visible light?
Electromagnetic.
It can release any type of electromagnetic radiation. It does not have to be visible light. I showed you visible light yesterday of electromagnetic radiation. Yes, my dear. 10. Mondays is 10 also. Yes.
What was the question?
Question number what? Question 4 is a photon. It's a particle that has a quantum of energy. Say what now? What? Remember which one? 4 is a particle that has a quantum of energy. So you said, yeah, you can say a particle of EMR. That's fine. All right. Can we talk homework?
Yeah.
All right. Let's see what kind of questions we have about that. All right. Let me find mine so I'll have the questions and I don't have to stare over somebody's shoulder. In question 1, what does the dual wave particle nature of light say? Passions. Let me get close. Yes. All right. Both electrons and light can behave as particles and waves. All right. What is EMR? Eileen. Yes. Give me some examples, Isabel. Yeah, you. We did it on Tuesday. That's why I gave you an easy question.
X-ray, ultraviolet.
Okay. I tried to go over easy there. What 2 properties tell us or identify all types of EMR, John?
Wavelength and frequency.
Good. So if I ask you to tell me what wavelength is on the quiz, you know what is one?
The distance between 2 corresponding.
What's their unit?
It's nanometer, centimeter.
All right. And what's their symbol? Very good. All right. What's the frequency, Brandon?
The way that past a human. I don't know what I wrote.
You don't know what you wrote. You need to write a little neater on the quiz because I need to be able to tell what you wrote. It's the number of waves that pass a given point in a given time. All right. Did you write down the unit?
Yes.
What was it?
Hertz.
What was the symbol?
It's like a slanted V.
Okay. All right. What's the relationship between frequency and wavelength? Anae? Okay. And number 8, what was the color, Angela?
Red.
Good. And what was the frequency?
Oh, I had a calculator.
You didn't have a calculator. What was the frequency, Caleb? You have a calculator? Okay. The frequency is 4.4 times 10 to the 14th hertz. Anybody need me to do that? Okay. What's the speed of light then, Caleb? It is. I was just looking for the number though. Okay. 3 times 10 to the 8. What's the unit? Meters per second. All right. What is the electromagnetic spectrum, Andy? Yep. All right. And then you determine it based on wavelength and frequency. What's the photoelectric effect? Alexis? If I tell you it's number 11, will that make any difference? Okay, so what's the photoelectric effect then, in case I ask you today?
Great question.
They are trying so hard to help you out.
When the light shines.
Shines on the metal and
It comes out.
the what thing? That will not get you any points on the quiz, because the thing comes out.
Electron.
There you go, that's a better answer. What is a quanta or a quantum fashion? It's number 12.
I got you.
You got it written down, I see that in there. So just read it off your paper. I even got closer so you didn't have to talk loud. A minimum amount of energy. Okay, I'm asking what photon is. Can you read that one to me? What's a photon? Somebody?
Oh,
A particle that has a quantum of energy.
yeah.
All right, how about 13? If I ask how energy and frequency are related, they're directly proportional. What's the ground state, Eileen?
Stay close.
And what's the excited state, Sheena?
State of higher.
Good. All right, what happens when an electron goes from the ground to the excited state? John?
Electrons absorb energy.
And what happens when it goes from the excited back down to the ground state, Brandon? It emits energy, or you can say EMR or light. All right, and then we jumped all the way down to number 23. What color is visible light with the shortest wavelength? An A. All right, so when you look at your reference tables. Oops, I don't need that. I can close that.
I'm pretty sure. Miss Hall,
Uh-huh.
can I get that sheet?
Yeah. And you really need to watch the video.
You really need.
Eileen really enjoyed the lesson. One of her favorite all-time lessons. All right, so when you look at visible light, right? I was being sarcastic. All right, shorter wavelength, longer wavelength, right? So looking at the colors, the question asks you for what? Shorter wavelength. Shorter wavelength's down here. So what color has the shortest wavelength? Violet. Okay? Now, the last question said which one had the highest frequencies. The chart doesn't have anything on it about frequencies, right? So, what do we know the relationship is for frequencies? They're opposites, right? Remember, they're inversely proportional. So if one goes up, the other goes down. So if you look at this and it says long wavelength, that means what about frequency? It's low. Okay, so this will be the low frequency. And if it's a short wavelength, that means it is a
Hi.
high frequency. Now you cannot write this on your chart, by the way. All right, so that's your high frequency because they're opposites of each other, right? So the question says, which type of EMR has the highest frequencies in the next or last question? So which type would have the highest frequencies?
Yeah.
Gamma rays, okay? See how you do that? Any questions? Fabulous. All right. What's what? 16 was if it goes from the ground to the excited state. So if we're in the ground and we have to go up to the excited state, we have to do what? We have to absorb energy to go up. I think I'm back at third period. Any questions? Brandon? What's what? Quanta is just a plural word for quantum. Quantum is the minimum amount of energy for an electron to either be lost or gained.
Can you put small packets of these?
Sure, sure. That's just multiple small packets because there's multiple quantums. Anybody else? All right. You need your blue chart. You don't need a calculator and a writing utensil. Because you're going to have to calculate for me. worse than trying to do what I do. Oh, and I only have Monday and next Wednesday till about 4:10. You know what it's up to. Okay? Alright, so does everybody have one?
Good.
Yeah.
Okay, we're on this manual, and I've seen him in the flesh, so I'm not gonna look at that. Well, he might have got some on that. His glass can fix it.
You don't have to be in complete sentences, right? Yours could be
Input D form.
like frequency notes.
I mean, we're still working. Sorry about your hands. Okay. Maybe you're working now. Everybody? All right, if you will, pass me to the front. All right. That wasn't so bad, now was it? Yeah, it was. Great, all a good grade so far. First period, y'all were gonna tell me y'all were terrible.
Yeah, last time.
I think we're
I already
ready.
forgot. I mean, I've only graded one terrible grade so far out of a whole bunch of them. And he clearly just didn't study. All right, let's finish up this history stuff so that Monday we are just doing the quantum numbers. Yeah, if you want to go do the thing with Miss Thornhill, your homework is going to be to finish the homework sheet that you were doing last night. You should be able to answer all of the remaining questions on that and just watch the video to make sure that you've got the rest of what you need. There will be a quiz to this stuff, and you are responsible for being able to do the quiz on Monday. Okay? All right, so going back to where we were. Let me just, whoops, that's not what I wanted to do first. I wanted to go back to here, here, minimize that, and find this.
No, it's all right. Outside, the streets, at my house. That's where the pepper is gonna, that's where the pet rally be.
I want it in the stadium. They won't do it. You know why? It'd be so much quieter. It'd be so much quieter outside. Wouldn't be deafening.
What time are they gonna start calling
You
you?
would look dirty though.
For the February?
According to what the schedule says, they will start calling us at 2:45. Now they're supposed to start calling band people around 2:30. Who's in the band? Y'all not in the band. You wear a football uniform for goodness sakes.
I'll play, I'm the band.
What instrument do you play?
I play trombone.
Yeah, right.
I think they tried to.
Uh-huh. No, you already wrote this. Now, yesterday, when we ended class, we said that elements had different line spectrums. Don't write this where you wrote it. They had different line spectrums, and they had different colors of light that we put on the countertop. Why? Why did they have different line spectrums? Why did they have different colors of light yesterday? Remember.
Location.
Because they have different
and different
Ah.
numbers of electrons.
Because they have different numbers of electrons, okay? They have different numbers of electrons and different locations. Now, one way that we talk about these locations is force theory. Now, the numbers of electrons, we talked about a week and a half into school, I think it was. So everybody should be able to look up, let's just say we did sodium, -23. Everybody in here at this point should be okay with protons, neutrons, and electrons. A couple people had issues on the benchmark, but most of us were okay. How many protons will we have? Somebody get me something to jab my eyeballs out. Better, I need some money to invest in my sheep
13.
or my
No,
alpacas.
it's not.
11.
Yes.
11.
That's okay. Brandon thinks there's 23. So seriously, I have really messed up. All right, there are 11 protons. So how many electrons are there? And how do I find my neutrons?
Subtract it. The protons from the
All right, so there are 12. All right, we all remember how to do that, right?
Yes.
Okay. Now, these 11 electrons right here are what we are going to spend our roughly the next multiple weeks talking about. Specifically the next week. We're really going to focus on those 11 electrons. Now, in the course of, I don't know, probably 8th grade, those of you who had a decent experience, is anybody writing that? You need me to wait? I mean, if you are, it's fine. I just don't want to have you yell when I turn the page. Can I turn? All right. In middle school, what? In middle school, chances are, if you had a real teacher, you drew some Bohr models. You might have even built one, okay? I still build Bohr models in physical science, even though part of this model is wrong, okay? We're going to talk about what's wrong with the model and how it was fixed today. But parts of the model are still very valid, and we still use them for very good reasons. Now, if I was to put together the model of sodium, does anybody remember how many electrons could go on the first ring of sodium? It is 2. Very good, Caleb. Anybody remember how many could go on the second ring?
3.
Yeah.
3. I'm just guessing. 'cause
Is
I know-
it the
1, 2,
25.
3, 4, 5, 6, 7,
It needs 8.
8.
Whoa.
Well, I said
I said 8.
I said 8.
We're going to talk about why it gets 8. But a lot of times, if you've been taught Bohr models, some people will know that it has 8 on the second ring. And the last ring to make sodium
10.
would only need 1. Can have 18. Okay, but since we're talking about sodium, I drew the Bohr model for sodium. Now, many some teachers will teach them as rings or shells. Doesn't really matter what name they used. We're going to call them energy levels because that's the correct name, which is why I listed it first. Now, the symbol we're going to learn on Monday is N. So this will be known as N equals 1, N equals 2, and N equals 3. Now, part of Bohr's model is we have to be able to read Bohr's model on your reference table on the back side. So, if we say something like N equals 3 to N equals 2, and they say, let's just say, what color of light is emitted, you would need to be able to read that off a table. Okay? So electrons go from a ground to an excited state. And when they go from the excited state back down to the ground state, they give off EMR. Now, from a third to a second energy level would be going back down, correct? So it's going to emit EMR. Since it asked you for the color of light, it's going to be visible light. Now, our job is to read that chart that's in front of you. So catch up to me, and I'm going to minimize that and pull up Bohr's model. This is a little easier to illustrate if I use the actual charts on the board. All right, we're there? All right, so if we look at the reference table, these are the rings, and the chart on the table has N1 to N equals 6, okay? This three set of arrows all points to N equals 1. Can everybody see those are pointing to N equals 1? Okay, my question said N equals 3 to N equals 2, right? So we don't want any of those because they all point to N equals 1. I want the one that points to N equals, let me use a brighter color. All right, I want the one that points to N equals 2, which is going to be on this ring. So I want the arrows that point right here because they're all pointing to N equals 2. Is everybody with me on that? Now, these are the lines that point there, but this line starts at N equals what? 6 and points to N equals 2. So that's not the one I want. This one starts at 5 and points to N equals 2. So that's not the one I want. This one goes from 4 to 2. So this one is 3 to 2. So this is the one I want. Right there, 3 to 2. So I read down, and what number goes with it? 656. We talked about yesterday, 656 is actually 6.56. So now if we cruise over here, where does 6.56 fit on the number line? It fits right here in red. 6.56 is bigger than 6.5 by itself. So it's a red color. So the light that would be emitted would be red. Now, if we go back over here and it asked us to do something like, let's just say, it said N equals 4 to N equals 2. If we went from 4 to, oops, I meant 4 to 1. I'm looking at the wrong line here. From N equals 4 to N equals 1. All right, and we followed this line down and we found this. Would that ask us the color? No, because this would put us in what range? It'd put us in UV. So it would emit a type of EMR, but would it be a light or a type of visible light that we could see?
No.
No. You would just say it emitted EMR. Okay? But it wouldn't ask you the color. Okay? Yes, ma'am.
So, the import.
Uh-huh.
The top one,
Say what now?
like import, the first number.
Mhm.
Letter, that's the one you go to, right?
You started the outside is the big number, and then you go to the small number on the inside. Yeah, so if I said, like, let's just say I said n equals 5, and I went to n equals 2. All right, so 5 is this one. Okay, and I was going to n equals 2, it was this one. So I'm going from the one that's got a dot to the arrow. So the dot has to be on this n equals 5 line. And I'm going to the one that the arrow is pointing at. So can you tell me which number has the dot and the arrow pointing from the 5 to the 2? Without y'all. Mm-hmm. Yep. And so if you had that, what color would you have? 4.3, yep, it's gonna be blue. You feel okay about reading that?
Yeah.
Okay. Everybody feel okay about reading that? All right, so the last part of put that calculator up. Y'all don't need calculators anymore. Y'all are dangerous. No, I said put your calculators up. I didn't say pack up. Y'all are dangerous. Before you have calculator smashed to smithereens.
This one?
You should try.
No, haven't decided.
Yeah.
You know, in my 20s, I did them all.
Yeah, you know what you can
In
do?
my 30s, I did a great many of them. In my 40s, I figured out my couch is a lot more comfortable. 48.
You can go to the game, because I was so close, you can just say you need to talk to me.
Okay.
But it's just out of
Why is it cut board?
That's his name, Niels Bohr. Niels Bohr is a famous scientist. There are 3 scientists that actually led to the development of quantum theory. But this is one of the pieces, when they stuck the photoelectric effect back in, they took out the history. And so part of the history they took out is the development of this. So Niels Bohr and Schrodinger are 2 that they left in, but de Broglie is one they took out. So I don't really have him in our notes for that reason. And the whole development of the atom they took out. You used to have to know who developed what about the history of the atom, like who discovered the nucleus, who discovered the neutrons, the electrons, all those things. That's all been taken out of the curriculum. But Bohr and Schrodinger have been left in. Otherwise, all the history has been wiped out. So other than just people who things are named after, those are the only people you have to know in the curriculum. These are the only 2 dudes left. Huh? In this one. Then I'm just going to free write. All the rest of it, everything we'll do on Monday is all free writing. Yes, sir.
Can I get a drink of water?
Sure. I'd never keep you from not having water. Hydration is the key to being successful in chemistry.
what is, I feel like that's a ritual, but.
It is. He's an electron. Say what? That was some serious sarcasm. That would be seriously true if we were in course class. But we're not in course class. Exactly. It was recyclable plant parts. Is it working out over there? The plant station. Okay. Well, she said she was hoping to make it neater, look better.
I thought we had 2 of those tables.
We did.
Where's the other one?
Behind Eileen.
Oh.
I moved it because I have They're actually, the classrooms that only have two, they're actually designed for larger students.
I'm wondering, can I sit there?
If you would like to. I don't care. So I have a larger child in one of my classes who sits there, so I moved one of those desks to that position.
I'm pretty large.
I don't think you need the definition. I'm not sure you do either, but they're designed for bigger students. They're designed for people like Wall.
Okay.
I'm pretty shocked.
Like, passion.
But
Passion.
they're not designed for folks like Passion, but she can certainly sit there if she wants to. Highly out of the chair. I want to sit here. All right. Is everybody caught up? All right, so when you look at Bohr's theory, the first thing that's in it is completely wrong. Okay? The first two parts of his theory are actually wrong. I know, I told you, there are parts of this that are wrong, but there are parts that are correct, so he still gets credit. The first two parts are actually the parts that are wrong. This part is the part that's correct. So if you think about what we just did, and I'm going to come back to those two pieces. If you think about the three parts that we just drew, and let's just say I number them 1, 2, and 3. All right, which of those would have the lowest energy? That's right. All right, so n equals 1 would have the lowest energy. All right, which one would have the most energy? 3. Okay, and we'll use that next week also. Now, from there, the two that I said that were wrong. In Bohr's theory, all right, he's saying that the electrons circle in those fixed circles or orbits, okay? He's saying, first of all, that the rings equal orbits. And the electrons have to be found on those rings. The electrons do not have to be found on those rings. And we're going to talk about why in a couple minutes, okay? Those electrons can be found in something called orbitals, and that was defined by Erwin Schrödinger. Hold that thought. Now, he also said that an electron can only move in between the orbitals.
Interruption. Teachers, at this time, could you dismiss all band students? Could you please dismiss all band students? Thank you.
You two are not in the band, sit still. Now, put it this way, I don't think you joined the band today. If you go to climb the rungs on a ladder, you've all done this before, you have to step on the steps or on the rungs. You can't levitate or stand between them, right? The electrons, same thing. They have to be on the rings. They can't sit or move in between them. They have to be on those things. For example, if I go back to Bohr over here, when I drew this, could I draw my electrons here? No, they had to be on the ring. That's what Bohr is saying. Now, he's also saying in number 2, when they go from here, they have to go to there. Or they can go from here down to here. They can't, again, be where? In the middle. They have to be on the ring. They can only go from one level to the other level and back down to the next level. They cannot be anywhere but on one of the rings. That's what he's saying about his model. That part is not correct. Okay? So, who fixed it? The Austrian scientist by the name of Erwin Schrödinger. Erwin Schrödinger proposed that electrons were found in orbitals. Okay? Instead of being orbits, he called them orbitals. Now, orbitals are areas of probability. Okay? It's where the greatest chance of finding an electron is. Now, generally speaking, if this is a ring, the greatest chance of finding the electron is somewhere around that ring. Now, that does not mean that the electron has to be there. Most often, it's going to be somewhere in that vicinity. However, does it have to be? No, maybe it's an outlier. It wants to be out here. Can it be out there? Yes, it can. For example, if Anae's mom showed up right now and wanted to get her out of class, where is the greatest probability of finding an A?
Here.
Right here in chemistry class. Mr. Kinzer, Ms. Beverly, whoever would look at the computer, it would say room 29 chemistry. They'd call down, they'd say send an A to the office. But does an A have to be in here? No, she could be in guidance, she could be in the bathroom, we could have left the room, we could be somewhere else, or an A could be somewhere else, but the greatest chance of finding her is here, okay? So, same with the electrons. When we draw the Bohr models, that's the greatest probability or chance of finding it, but does it have to be there? No, it's going to be pretty close though. Now, what else did he do? He said that electrons can be or behave as both particles and waves. Bohr said particles. The scientist that I'm not telling you about, de Broglie, he said waves. Schrodinger put them together. Now, the final thing that's important that leads us into our Monday discussion is he wrote a mathematical equation to describe the location of an electron. Now, this mathematical equation would be very long. It has lots and lots and lots of Greek letters in it. Okay? We're not going to write the mathematical equation. We're not going to do anything with it. But out of this equation comes the 4 quantum numbers. Okay? Now, these 4 quantum numbers are going to do what again? These 4 quantum numbers are going to tell us the location of the electron. It's like our address. You guys have a street number, a street, a city, and a state. Quantum numbers have something similar to that we're going to work with on Monday. Now, because of all of that, Schrodinger is known as the father of modern quantum theory. Now, for homework, you should be able to finish the worksheet that I gave you yesterday. And you should be prepared for a quiz on Monday. Because I am not going to start the 4 quantum numbers with approximately 7 minutes until they start calling us. And I do not trust them to wait a full 7 minutes. I've been down this rodeo with them before.
What's the quiz on?
What's the quiz on? The rest of the worksheet. If you can do the worksheet, you should be able to do the quiz. Anything and everything from yesterday, Tuesday, if you can do the worksheet, you can do the quiz.
These are stuff, right?
No,
We're leaving right after.
For real?
Yeah, for real.
it's Friday. You get back here late,
Oh, shit.
I might turn you into a speed bump in the parking lot.
So let's try to.
Say what? Yes, take your stuff.
I'm asking.
It's Friday.
We have a quiz on
Okay.
Yeah.
Right.
Didn't I just say you got a quiz Monday?
Monday.
Y'all sit down. Good God.
Friday.
Austrian people from Austria, right?
Yes, Austrian people are from Austria.
I was thinking Australia, but that's Australia. Cambodian? Not, I mean, not all of them. It's true about anything. Well, why is it?
Here, Al, you want to hand me Passion's calculator and look up for?
Call me Allie.
I said Ilea. Hold on. I may have said Allie. That means if I did.
You say I really quick, so it's like Allie. Allie.
Miss Richter called me Allie today.
She called her Allie, but she was Allie.
Allie, shh.
Like, I'll be turning around, but I won't be talking.
She was like referring to me and she was like,
At this time, dismiss the football players and the cheerleaders.
Yeah, I don't know.
Stop.
How are they gonna listen?
Ah.
By hall or by like class?